Okay, we're going to talk about the difference of two squares. Now, what am I talking about? What's the word difference imply? Subtraction. So I'm really going to be taking a square and subtracting another square from it, right? No, I'm not.
Makes sense to me.
Makes sense to you, doesn't it? That's exactly what, when you think about it, that's really what we're going to do. If you want to think of it graphically like that, we're going to take two squares and we're going to subtract them. Now, really, what am I talking about? The reason I drew a square is because it's a representation of a squared number. What do I mean by a squared number? 2 squared is 4. 4 is a number that we call a perfect square. Okay? X squared is a perfect square. Okay? X to the 8th is a perfect square. It doesn't have to be to the second power. It just has to be to an even power.
So x to the 7th is an imperfect square.
X to the 7th isn't a square, is it? It's not a square. Now, why do we call these perfect squares? Why do you suppose we call them perfect squares?
Because they're perfect. Because they're not prime. They go into each other.
No. What, Felix? Okay, I don't have time for people that forget. Here you go. Okay, what happens if this square is x by x? What happens to the area inside? What do I get in the area?
Small.
What is the area?
X to the second power.
X times x. X times x is equal to the area of that square. If this one is 2 by 2, we know we get the area is 4. 4 is a perfect square. Why am I using the symbol of a square for these? So that you can see that this is the difference of two perfect squares. Okay? And this is why we call them squares. Because we actually have a square and it represents the area. So whenever you have something like that, because you know in a square all 4 sides are the same length, right? That's a perfect square. It's not a rectangle. Okay? So now let's take a look at what we're really going to be talking about for numbers. I said that we have two perfect squares. Let's take x squared minus 4. This is a polynomial. It's a binomial, which is a specific kind of polynomial. It has 2 terms, okay? And both of them are perfect squares, right? We already said that x squared and 4 were a perfect square, okay? And it's also the difference. It's not the sum, it's the difference. That's an important point right there. Okay? You got to have the difference and you got to have 2 perfect squares. So what do we have? We have a quadratic, don't we? A quadratic, because it is to the second power. So this is a quadratic expression, not a linear, which would be a straight line. Okay? Now, how am I going to factor it? This, believe it or not, factors into the product of 2 binomials. Now, what's going to happen in this binomial is really cool, because I'm going to take this binomial and I'm going to say, okay, remember how I showed you that if you were going to factor it, we were going to still use this method? I have the product of these 2 that's going to give me x squared, right? And the product of these 2 is going to give me minus 4. Okay, what am I going to put here and here to get x squared?
X.
X. X. And what am I going to put here and here to get negative 4? And they've got to be the same.
Positive 2 and negative.
A positive 2 and a negative 2, right? They got to have different signs, okay?
Man.
Now, what's really cool about this is when you think about this, these are things you're just going to have to recognize, okay? What am I going to get for my inside? Plus 2x. And for my outsides, I'm going to add to that a minus 2x. So what happens to my middle term when I add these two together? I get 0 x's. And that's why this thing over here has no middle term. It has no linear term in there. Okay?
The answer just be
Now, no, this is the factor of that.
But if
You don't put this in because there's none. What we call it is it falls. It drops out.
So is the answer X?
What answer? There's no answer. I'm not solving it.
Oh.
Okay, I'm not solving it. What I'm doing is I'm doing what's called factoring, which is like prime factorization. I'm breaking it apart. Remember the Legos? We're breaking them apart into all their little pieces together. All the little pieces separate that we can break apart. Right? Okay, so what we're doing is we're taking this thing and we're making it simpler for us to understand what's going on. So now, here's the important part about these is you have to be able to recognize. Recognize. Let me give you some key features of these. First of all, you know it's the difference of two perfect squares, right? So when you think about it, I have subtraction,
Multiplication.
so the minus sign better be there, and it's two perfect squares, so there are two terms, okay, to these things, so they're binomials. Let me write that, because it is a vocabulary word you should know. Okay? So if you see two terms with subtraction between them and they are both perfect squares, both terms perfect squares. Okay? When you recognize something like this, it's going to look like this. A squared minus B squared, and what is that? It's going to factor into
0.
the product of two binomials, the first of which will be A plus B and A minus B. Okay? What did I do? Sometimes I call this, when I try to remember to remind you when you're in Algebra 2, okay, don't forget, that's the difference of two perfect squares. It's a pluser and a minuser. That middle term's dropping out, okay? That's what I say. I call it a plus and minuser, okay? So when you factor these things, you're always going to put two sets of parentheses. You're going to put a plus sign in one, a minus sign in the other, and basically what you're going to do for this is you're going to actually take the square root of A squared, which is A, and you're going to put it in the first slot of each binomial, and you're going to take the square root of B squared, and you're going to put it, the second term, and you're going to put it in this slot. Now when I say square root, don't let that bother you, because intuitively you already know what that is, okay? You know that if I have 4, okay, 9, 16, 25, 36, 49, that all of these integers are perfect squares, aren't they? Okay?
They equal something.
Well, the square root, they are perfect squares because they are a number times itself, right?
Yeah.
Okay? This is 2 squared, this is 3 squared, this is 4 squared, 5 squared, 6 squared, and 7 squared. Okay, I could go on. Okay? 8 squared is 64, and then we have 9 squared is 81, and everybody knows that 10 squared is equal to 100. So there you've got your first bunches of them from 1 to 100, your perfect squares, 2 to 100. You know them all. Okay? The variables are the easy part. the variables, all you have to know to have a perfect square in your variable expression is that both exponents are an even power. 2, 4, 6, 8. Who do we appreciate?
Me.
Perfect squares, right? Okay, let's go on. Okay, so what I'm talking about is something like, let's take here's some that you won't know that I'm going to tell you what they are. 11 squared is 121, which you'll see quite a bit. So when you see these numbers, something ought to click in your brain. You ought to say, perfect square. Is that a difference? Is the first one a perfect square? The second one a perfect square? Are they both perfect squares? I know how to factor this, right? That's what you're going to do. Because these are going to be easy, right?
Yeah.
Isn't 12
12 is 144. So everybody know what 13 is? 169. Okay. You can do these on your calculator, okay? I've done them for years, so I recognize them when I see them, okay? 225 is 15 squared. There's things like that that I see that I instantly know that they're a perfect square. So your job is now tonight to recognize perfect squares. So let's do some examples off this study sheet. I'm going to do the odds, and we're going to show you how to factor these perfect squares. Okay. Oh, the first set, they're just going to write them as a binomial. Why? Because a plus 3 times a minus 3. When you see this, you know instantly when you have the sum and difference, and the only thing that's different about these is the sign. You have two different signs, but the same exact binomial. You know that all you have to do to do these is you can skip the middle term because you know it's going to be 0. Right? So all you have to do is take a squared, and you know it's going to be a minus 9. 3 squared. Okay?
That's the answer.
That's the answer. Okay. X plus 5 times x minus 5. What am I going to write?
X squared
X squared
minus 25.
minus 25. Does everyone see what we're doing?
Yes.
Okay, we're doing the opposite. We're multiplying them now. I've already showed you how to put them together, okay? Now, how about this one? 5a plus 2 and 5a minus 2. What am I going to get?
25,
25a
Second power.
squared. Remember, these are always going to be even powers over here when you're multiplying.
Okay.
Minus 4. Okay? So when you recognize, look at what you're seeing is the difference of two perfect squares. 4 and 25a squared. Okay? And that's really what you're going to try to recognize when you try to factor these. Okay? Let me go down and do some other ones out of the other set. The second side of the page. I want to go to the second side of the page, so flip over. Okay? All right. I'm not really quite sure what they want to do in 17 through 24, so skip those for right now because I want to go on and do 25. B squared minus 16. B squared minus 16 is equal to. Now I'm going to be going the other way now. I'm not going from the factored version to the simplified version. Now I'm breaking it apart. So instead of putting the Legos together up here, I'm taking them apart. So what am I going to get?
You're going to get B minus 4.
B, say plus 4 minus 4, right?
Yes.
Yes.
Okay? So, number 27, 36 minus x squared. It's the difference of two perfect squares, so what am I going to factor it into? Do you get these, Elise? What am I going to factor this into? What's the square root of 36?
6.
minus and a plus, or a plus and minus. So as long as they're different, and you got the same exact thing in both of them. Now, don't make the mistake of putting, even though 6 plus x is the same as x plus 6, put them in the same order so that you see them, okay? Alex? The number 17, yeah, I said I'm going to skip that for right now because I wanted to go on and do the others, okay? So now you see how to do these. Let me look and see. Basically, these are pretty easy down here, so that section. So let's go to the top. It says multiply using this pattern, the quantity a plus b times the quantity a squared minus b. And they have two numbers. So what are they doing is they're trying to take those numbers, okay? If you'll say 16 times 24. I want to represent 16 as the difference of two numbers or the sum of two numbers, and 24 is the difference in the sum of two numbers. And those two numbers are the same. So what I really want is, okay, this product to be represented as, okay, use the pattern a plus b times a minus b. Okay, so what we really want is something plus another number is equal to 16, right? And we want the same something, a, because a is equal to a, right? Minus the b to equal 24, okay? What number plus another number is equal to 16? What are my possibilities?
8 plus 8.
8 plus 8, but is 8 minus 8 24?
Yes.
No.
It's
3.
Okay, what is it?
4. 3 times 8.
How about, if I want to get 16, what is it?
4 times 4.
How about, I don't want times, Desiree, I want addition. Okay, so as we said, how about 16 and, or 15 and 1? Right? That's one way of getting 16. 14 plus 2. 13 plus 3. You see all the different possibilities?
8 plus 8.
Which one of those starts with the same number over here, but it's the difference? So take all these. 15 minus 1 is 14. That's not 24. Right?
You'll never get a solution.
Well, I will.
I'm confused.
Okay, well maybe, possibly, if you think about this long enough, do you have negative numbers involved here?
Okay, you have -4 for B.
Or how about 4, what,
If you put -4 for B and you put 20 for A.
20 for A, so 20 and -4, 20 and -4, but -4 doesn't have a square root.
2 times 2.
Did you notice what we just learned?
Ah, no.
What did we just learn?
Oh, this
The
is
square root of a negative number. You can't do that, can you? Because you got to have either two positives or two. To get a negative number, you have to multiply a negative and a positive, and they're not the same number, are they? Okay, so what are we going to put in here? How about we're going to add two numbers to get 16, subtract two numbers to get 24. What do you think? This is tricky, isn't it? You have no idea.
I give up.
20 plus negative.
Well, think about two numbers I can add together to get 16.
8 plus 8.
8 and 8.
20 plus -4. I
Put
just said that.
negative.
You can't do
That kid.
-4.
I just said that like 5 minutes ago.
You did?
Yes, I did.
7 and 9.
I'm going to die.
So what we're looking for is an A here, Alex. Okay. Oh, gotta get this right thing. We're looking for an A here and a B here. When I add them, I'm gonna get 16, and when I subtract them, I'm gonna get 24. Think about it, and let's see what you can come up with, okay? You're doing the evens for homework.
Yeah, I'm not testing nothing for you.
So how are we gonna do that for